Hello everyone. Um, in the last lesson we discussed fractions, and in this lesson we start with the real algebra with mathematics of equations. So to define equation, an equation is basically an expression that describes two quantities that are separated by an equal sign, quantity 1 and quantity 2. And this equal sign means that the quantity on this side is equal to the quantity on this side. Now let's start with equations involving a polynomial with degree 1. So that's the first one, equations involving x to the first power. These type of equations are in the following form: ax plus b equal to 0. The solution to all of these equations will be in general. When we solve this, we need to isolate the x. So to isolate the x, we apply the following. Basically, we subtract b from both sides. The main procedure in solving any equation is applying equal operations to both sides. So when we subtract b from this side, we have to subtract b from this side, because supposedly this is quantity 2, this is quantity 1. So this side is equal to this side. Now to keep the equality, whatever we do to this side, we have to do to this side to keep them equal. So we subtract b from both sides, and what we're left with is b minus b is 0. So we get on the left hand side ax, on the right hand side minus b. Now to isolate the x, we divide by a. We divide by a on the other side, so we could cancel this a with this a, and we're left with x equals minus b over a, and this is the general solution to the equation involving x to the first power. Now let's take a look at equations involving x to the second power, or x squared, or they're also called quadratic equations. And quadratic equations, they take the form ax squared plus bx plus c is equal to 0. To solve this type of equation, there are two types of solutions. The first one is factorization. Sometimes a, b, and c will be numbers that could be factored, and we could form two factors that, if multiplied by each other, they result in the same equation. So that's basically a decomposition, to decompose this equation to two factors involving x to the first power. And if we could decompose this into two factors involving x to the first power, then we could solve it, because we have this zero, and the solution will be achievable. So to kind of do that, we need to know the values of a, b, and c. But there is also another way, which is through the quadratic formula. Now, for me to address the quadratic formula, I have to show you how to derive it. And to start deriving the quadratic formula, we will have to try to get the x by itself. So that will happen as follows. We start by subtracting c from both sides, just to get rid of this c. So if you do that, we'll get this equation, ax squared plus bx is equal to minus c. Now we need to get rid of the a. So to get rid of that, we divide both sides by a. Now on the left hand side, when we have two factors added or subtracted, as in this case, divided by a denominator, we seen in the previous lesson of fractions that a is also called the common denominator, meaning it would be, if we write this whole fraction as two separate fractions, then a will be the common denominator for them, meaning a will be the denominator for both. So we could actually rewrite this as ax squared over a plus bx over a. Now we get to this form of this equation. A cancels with a, and we have x squared plus b over a x is equal to minus c over a. Now the next step involves something called perfect square. And perfect square, let me put it as a subnote here, perfect square. A perfect square is a square of the following form: x plus a all squared is, if we multiply this out, it will be, okay, if we separate it first. So if we multiply this out, we will multiply, let's say, the x by this quantity, and then the a by that quantity, and we add them together. So x times x plus a plus a times x plus a, and this will equal to x squared plus ax plus ax again plus a squared, and this will equal x squared plus 2ax plus a squared. So we see that this form here is actually equal to this form. Now, comparing our equation here to this perfect square, we could see that we need this a squared and the 2a is actually equal to b over a in that case, in the case of our polynomial. So to kind of compensate for that, we will do the following. So we will start with x squared plus b over a x. Now we need to add the perfect square, which is something similar to that, of that form. It doesn't have to be a. Basically, this a is not equal to this a because they denote two different numbers. Okay, I just used it as a placeholder for a constant. So in this case, to make this a perfect square, we need to come up with a number that actually, so let's compare it. Let's compare the b over a. Let's call this, just to differentiate, a0, such that a0 is not equal to a, just for us to kind of compare. So when we compare, we will try to figure out what a0 is. If we could figure out what a0 is, then we could add it to make a perfect square and also subtract it to keep the equality. So this will involve the following. Let's find out what a0 will equal in this case. So we have the coefficient of x involves these two factors, the coefficients of x. Now, this concludes that 2a0 is equal to b over a. Now, to solve for a0, we divide both sides by 2. This divided by 2. So, we see that a0 is equal to b over a divided by 2 over 1. So it's division of two fractions. So we turn into multiplication by 1 over 2. We flip this last fraction and it will be b over 2a. So this will be a0. Now, if we take this x squared plus b over ax, now we need to add this a0 squared to make it into a perfect square. So a0 is here, so we need to add b over 2a squared, And to keep the equality, we could also subtract it. So we add the same thing and we subtract it. It will be just adding a zero to this. And adding a zero doesn't change the equality. Minus c over a. Therefore, by comparing this quantity to the perfect square, we get that this here could be compared to this, and it could be rewritten in this form here. So what we have is the following. Okay, so you can see that it's gonna be equal to x plus a0. Where is a0? It's b over 2a squared minus b over 2a squared is equal to minus c over a. So we could basically subtract or add, since this is in minus, we could add this same quantity, b over 2a squared, to both sides. B over 2a squared. Now, by adding these two quantities, they cancel or they become 0. And those two quantities add up, so it's x plus b over 2a squared is equal to b over 2a minus c over a. Now on the right hand side, we could take a common denominator to be 2a. So it's equal to 2a. To make the right side into 2a, we multiply by 2, we divide by 2. So it becomes b minus 2c. Oh, there is a mistake that I just committed, and it's very easy to make mistakes. Now, if we add that square, it will change everything. Let's just rewrite it into b squared over 4a squared minus c over a. Now our common denominator is actually 4a squared. To make this side into 4a squared, we multiply by 4a divided by 4a. So what we get is 4a squared as a common denominator, b squared minus 4ac. Now this is equal to x plus b over 2a all squared. Now we take the square root of both sides. This square root cancels with the a square. So what we get is x plus b over 2a is equal to, and in the right hand side, when we take the square root, we have to add a plus or a minus sign. because the plus of this quantity and the minus of it will give us the same answer, because when you square, let me put as a subnote, if x equals a and x equals minus a, and let's say x0 equals minus a, then x squared is a squared, and also x0 squared is also a squared. So we see that when we square a negative number and a positive number, we get the same answer, which is a squared. Therefore, we include this plus or minus sign. Now we could split the square root to numerator and denominator, so it will become plus or minus. This plus or minus could be just added to the tab root, forgot a C there, and the bottom is actually a perfect square, so it's square root of 4 is 2, square root of a squared is a. So we get this. Now by looking at the left hand side and the right hand side, we could subtract this quantity and subtract it from both sides to get rid of that. So x will equal to plus or minus square root of b squared minus 4ac divided by 2a minus b over 2a. Therefore, x will equal to minus b plus or minus square root of b squared minus 4ac divided by 2a will be the final answer for our x. That involves a quadratic equation in this form. So this form of equation in general we could find what x is by knowing a, b, and c according to this equation here. And we see that if we know a, b, and c, we could get the values of x, because it will have two values, because we have a plus and a minus sign. The plus will give us one value, the minus will give us one value, and this is enough for this lesson. I'll continue on the next one.